Hello and welcome to this tutorial. From this tutorial we will understand Google stock price prediction with RNN and LSTM. Let us begin. First we have to do installation and setup. Pip install TensorFlow GPU execute. It will take some time to install. After the installation, import TensorFlow. Import TensorFlow as TF execute. Now check the version. Print TF dot version execute 2.0. So we have successfully installed and imported TensorFlow 2.0. Now import other libraries. Import numpy as np. Then import pandas as pd. And after that import matplotlib dot pyplot as plt. Execute. Great. So we have completed installation and setup. That is, first we have installed TensorFlow GPU version. After that we have imported TensorFlow and verified the version, and then we have imported these three important libraries: numpy, pandas and matplotlib. Now we have to do data preprocessing. Add one more section. Step 2, data preprocessing. Great. Now we have to download the Google stock prices. To do that, go to this website finance.yahoo.com/code/GOOG/history. Now scroll down. From here we can download the data. You can see here, first option is time period. Now click here. We can select start and end date. So here I will download two different datasets. One is for training and one is for testing. For the training purpose, I will download data for 5 years. That is from November 2014 to October 2019. And for the testing purpose, I will download data of November 2019. I have already done that. So cancel. Let us explore the dataset. So these are the two datasets, training set and test set. Open training set. In training set we have data of 5 years. November 2014 to December 2019. Total 5 years. And these are the columns: date, open, high, low, close, adjacent close and volume. Let us understand these columns. First column is date. Second column is open stock price of that day. Then the highest stock price of that day. Then the lowest stock price. And this is the closing stock price. And after that adjacent close. And at the end volume. So there are total 7 columns in this dataset. Let us check the number of observations. (1258) minus 1, 1257 observations. We are not considering this row as observation, the first one. So total number of observations are 1257. Now close this. Check the test data. In testing data, there are same number of columns, these 7. And there are total 20 observations. These 20 observations are of the month November 2019. Now close this. Go back to Google Colab notebook. First we will import the dataset to Google Colab. Importing the dataset. From google.colab, import files. Define an object uploaded. Files dot upload. Execute. Execute one more time. Great. Choose files. Select these two files. Open. Great. Now these two files are in Google Colab. To see these files, click on Files, refresh. You can see here test_CSV and training_CSV. First we will read this file, training set. Define a variable training data pd dot read_CSV. Copy path and paste. Execute. Great. Let us explore the training data. Type training_data dot head. Execute. So these are the first few lines of this data. You can see the date 3rd November 2014. This is the first stock price of November 2014. Let us check the tail. Training_data dot tail. Execute. So these are the last few lines of training dataset. You can see the date here, 30 October 2019. So in training dataset we have stock prices from November 2014 to October 2019. Now check the information. Training data dot info. Execute. So there are total 1257 entries from index 0 to 1256, and there are total 7 columns. These are the column names: date, open, high, low, close, adjacent close and volume. And these are the number of entries in these columns, 1257. And this is the object type. Add one more cell. Now define one more variable, training set. This will be the actual data on which we will train RNN network. Type training data dot iloc. We will select all the rows. In training data we will select only one feature, this one, column open. Now scroll up. In Python programming, index location starts at 0. So we have to select this column as feature, index 1. But we want to select array, so add the range, :2. In Python programming, upper bound is excluded. Index location starts at 1 and upper bound excluded. That means we are selecting only one column. This one, column open. By doing that, we are making an array. Till now we have selected a data frame. To convert this data frame into NumPy array, type dot values. Now it is a NumPy array. Execute. Great. Let us check the information about training set. .info. Execute. So it has no attribute. Let us check by another way. Training set dot shape and training data dot shape. Execute. So in training set there are total 1257 observations, and same in training data 1257 observations. But note down here, these are the number of columns. In training set we have selected only one column, and previously we have 7 columns. So in training set there are 1257 observations and one column. After selecting the training set, we will apply feature scaling. Now note down here, there are two ways to apply feature scaling: standardization and normalization. This time we will do feature scaling with normalization. In RNN, we use normalization. First we have to import the library from sklearn.preprocessing. Import min max scalar. Now define an object here, sc. We are defining this object of this class min max scalar. Min max scalar. Here we will specify one parameter, feature range 0, 1. Now define one more variable, training underscore set underscore scaled. So this will be the training set after feature scaling. Type this object sc, then apply the method fit underscore transform, and in parentheses training set. That's it. Execute. Great. So we have successfully applied feature scaling. Let us check the data set. Training underscore set underscore scaled. Execute. Great. As you can see here, these values are scaled. Let us revise what we have done in this tutorial. First we have completed installation and setup. That is, first we have installed TensorFlow GPU version. After that we have imported TensorFlow and verified the version. Then we have imported these three libraries, NumPy, Pandas and Matplotlib. After that we have started data pre-processing. First we have imported two files, test set and training set. Then we have created a variable training data, and in training data there are total 1257 entries from index 0 to index 1256, and there are total 7 columns in this training data, and you can see other details here. After that we have defined one more variable, training underscore set. This will be the actual data on which we will train our RNN network. In training set we have selected only one column, this one, open. And after that we have applied feature scaling. Now note down here, there are two ways of applying feature scaling, standardization and normalization. Here we are doing normalization. And to do that we have imported this class min-max-scaler from this library sklearn.preprocessing. So this tutorial ends here. I will see you in the next one. Till then, happy learning. Hello and welcome to this tutorial. In previous tutorial we have completed installation setup and started data pre-processing. In data pre-processing first we have imported the dataset. Then we have created this variable training data. And after that we have created one more variable training set. So this is the data on which we are going to train our RNN network. And after that we have applied feature scaling. Now we will create a data structure with 60 time steps and one output. Let us understand this first. So here we are creating a data structure with 60 time steps. 60 time steps is the training data for our RNN network, and on the basis of these 60 time steps one output will be predicted. Now define two empty lists. First one is the xtrain and second one is ytrain. We will append the data in these two empty lists, xtrain and ytrain. Now use the for loop. For I in range, as we have discussed, RNN network is going to predict one output on the basis of previous 60 stock prices. So these 60 time steps is the past information for RNN to learn and understand the correlations. And on the basis of that understanding, our network will predict the output. Specify lower bound is equal to 60. Now we have to define the upper bound. Scroll up. So there are total 1257 entries in our dataset from index location 0 to 1256. So we have to select all these observations from index 0 to index 1256. So specify upper bound is equal to 1257 because upper bound is excluded in Python. Now type xtrain dot append. In xtrain we will append 60 time steps for each output. Training set scaled. First we have to specify the lower bound, that is I minus 60, and upper bound is I, comma 0. Let us understand this. In training set, we have to select 60 time steps for one output. So I minus 60. Suppose I is equal to 60. This one, lower bound. That means 60 minus 60, 0. Lower bound is 0. And upper bound is 60. In Python programming, upper bound is excluded, 0 to 60. So it will select from index 0 to 59, total 60 values for one output. And 0 is the column index, as there is only one column. Now type ytrain dot append training set scaled. In training set we will select actual output, that is I, comma 0. Let us understand this again. Here we have to create a data structure with 60 time steps for one output. So these are the 60 time steps and this is one output. Suppose I is equal to 60. 60 minus 60, 0. Index location 0 to 60. That means 0 to 59 will be selected. total 60 values in X train and in Y train I, that is 60. So for these 60 values, this one output. Now X train and Y train are the lists. We have to convert these lists into NumPy array. Let us do it. Type X train, comma Y train is equal to np.array X train, comma np.array Y train. That's it. So here we are converting these two lists, X train and Y train, into NumPy array. I will note down here. Converting X train and Y train into NumPy array. Great. So here we have successfully created X train and Y train, that is data structure with 60 time steps, that is X train and one output, and at the end we have converted these two lists into NumPy array. Now execute. Great. Check the X train. So there are 60 values in first observation, this one, from index 0 to 59. Similarly, there are 60 values in second observation, from index 1 to 60. In first observation index 0 to 59, in second observation from index 1 to 60, in third observation from index 2 to 61, and so on. So this is our data structure. Similarly, we can check Y train, type Y train, execute. So these are the outputs. So we will train our model on X train and Y train, data in X train and output in Y train. With this data and this output, our model will learn the correlations. Now check the shape. Type X train dot shape, execute. There are total 1197 observations and 60 columns. We have to reshape this data set. Reshaping the data set, because RNN network will take input in the form of 3 dimensions. Type X train is equal to X train dot reshape. First dimension is 1197, second dimension is 60, and third dimension is 1. Let us understand this. 1197 is the batch size, that is total number of observations. Then 60 is number of time steps, that is total number of columns. And 1 is the predictor, that is indicator, or we can say 1 Google stock price. Now execute. Great. Check the shape again. Copy, paste, execute. Now it is in 3 dimensions. So this tutorial ends here. Let us revise. After installation setup, we have started data pre-processing. First, we have imported the dataset, and this is the actual dataset on which we are going to train RNN network. After that, we have applied feature scaling, and then we have created a data structure with 60 time steps and 1 output. And at the end we reshaped the dataset. So this tutorial ends here. I will see you in the next tutorial. Till then, happy learning. Hello and welcome to this tutorial. Till now we have completed installation setup and data pre-processing. In this tutorial we will build LSTM, that is, we will build our network. Let us begin. First we have to define an object. Define an object. That is, we are initializing the network. Initializing RNN, Recurrent Neural Network. Now define an object model is equal to tf dot keras dot models dot sequential. So we are defining the object model of the class sequential. Now execute. Great. After initializing the recurrent neural network, we will add LSTM layers. First LSTM layer. To add LSTM layer, type model dot add method in parentheses tf dot keras dot layers dot LSTM. Here we will add 4 parameters. First one is number of units, then activation function, after that return sequences, and at the end we will add input shape. First add number of units. Units is equal to 60. These are the number of cells or memory unit that we want to have in this LSTM layer. Then add the activation function. Activation is equal to, by default activation function is tan h, but we will add activation function as relu. Activation function adds non-linearity into the network. After that add return sequences. Return underscore sequences is equal to true. Now note down here, after this LSTM layer, we have to add more LSTM layers. Hence, we want this layer to return the sequences. If we were going to add a dense layer after this LSTM layer, then we wouldn't want to return the sequences because the dense layer will not understand that. But here we are adding more LSTM layers. Hence, we have to add this parameter, return sequences. And after that add input shape. Scroll up. This is our input shape 60,1. 60,1. That's it. So we have successfully added first LSTM layer here. The LSTM layer will be used to understand the relationship between different elements of a sequence. Now after that add a dropout layer. Dropout layer. Model.add tf.keras layers dot dropout. Dropout neurons is equal to 20%, that is 0.2. Adding the dropout layer is a regularization technique. Here we are dropping 20% neurons from the training. Now we have to add more LSTM layers. Copy these 2 lines. Paste. Second LSTM layer. Let us check the parameters. First parameter is same, that is units is equal to 60. Activation function is also same, relu. We want to keep return sequences. Then delete this parameter, input shape. We have to add input shape at input layer, that is first layer, this one. Here we have to add 2 more LSTM layers. Copy these 2 lines, paste, paste again. Third LSTM layer. In third LSTM layer we will change only one parameter, this one. Number of units is equal to 80. Activation function is ReLU and return sequences is equal to true. And same percentage of dropout neurons, 20%. And this is our last LSTM layer. Fourth LSTM layer. Add number of units is equal to 120. Then activation function is same. Now delete this parameter, return sequences. We are deleting this parameter because after this LSTM layer, we are not going to add one more LSTM layer. That is, after this LSTM layer, we will add a dense layer, and dense layer will not understand this return sequences. Now execute. Great. So we have successfully added 4 LSTM layers and 4 dropout layers. Now add output layer. Model.add tf.keras.layers dense. In the output layer, we will specify only one parameter, this one, units. Units is equal to 1. Let us understand this. There is only one possibility in the output layer, and this is because we are predicting real values corresponding to stock price. So there will be only one dimension in the output. That's why we have specified units is equal to 1. Now execute. Great. Now scroll up. Here we have built our model successfully, that is LSTM network. First we have defined an object, that is initialized the RNN network. Then we have added 4 LSTM layers and 4 dropout layers. And after that we have added output layer. Let us check the summary. Model.summary. Execute. So this is the sequential model and these are the layers. LSTM layer, dropout layer, LSTM dropout, LSTM dropout, LSTM dropout. 4 LSTM layers and 4 dropout layers. And at the end this is the dense layer, that is output layer. These are the parameters and here we can see output shape. And at the end we can see that total parameters, trainable parameters and non-trainable parameters. So this is all about the summary. Now we have to compile the model. After building the network, we have to configure the learning process, and to do that we compile the model. Type model.compile method. Here we will specify 2 parameters, optimizer and loss function. Specify optimizer is equal to, by default optimizer is RMS prop, but we will specify optimizer is equal to Adam. In recurrent neural network, RMS prop optimizer is recommended, and this is because it is an advanced stochastic gradient descent algorithm. But here I have specified optimizer is equal to Adam. For this specific example, I have tried both the optimizers, RMS prop and Adam. But the Adam optimizer is giving better performance than RMS prop. That's why I have specified optimizer is equal to Adam. Now specify the loss function. In this example, we are not going to do classification. Hence, we will not specify loss function is equal to binary cross entropy. Here we are dealing with a regression problem. Hence, we will add loss function is equal to mean squared error. Mean underscore squared error. Now execute. Great. Till now we have built the network and we have compiled the model. Now we will train the model. Add one more section. Step 4. Training the model. To train the model, type the object model dot method fit, and in parentheses we have to specify the parameters. Specify x train, comma y train. Then we will specify the batch size 32. On how many iterations we want to train the recurrent neural network, and this size is our batch size. We will train the network on the batches of observations. 32 observations per batch. Then specify epochs. Epochs is equal to 100. How many times training data is forward propagated inside the neural network and back propagated to update the weights. So here we will do this process 100 times. Now execute. Training process is started here. You can see epoch 1. It will take around 15 minutes. So we have successfully trained our model here. Now scroll down. 100 epochs. Let us revise. So in this tutorial, first we have built our LSTM network. After that we have compiled our model, and then we have trained our model. So this tutorial ends here. I will see you in the next one. Till then, happy learning. Hello and welcome to this tutorial. In previous tutorial we have built the LSTM network and we have trained the model. In this tutorial we will make predictions. Let us begin. First we will get the real stock prices of the month November 2019. Getting the real stock prices of month November 2019. Create a variable test underscore data pd dot read underscore csv. Now go to files, copy this path of test underscore set, paste, execute. So this is the test data. Let us check the shape. (20,7). So there are total 20 observations and 7 columns. Let us check the information for the same. (20 entries, that is 20 observations from index 0 to 19, and there are 7 columns. These are the column names: date, open, high, low, close, adjacent close and volume. But for the testing purpose we have to select only one column, this one, open. Let us do it. Define a variable real stock price. Specify the test data, that is test underscore data dot ilog. Select all the observations. Then we have to select column, this one, open. Index location for this column is 1, 1:2 dot values. As you know that in Python programming upper bound is excluded. Here upper bound is 2, index 2. Index 2 for this column, high. So this column will be excluded. Hence, we are selecting only one column, this one, open. And we are doing this because we want an array. Now execute. Great. Let us check this variable, real stock price. This is the information in this variable. Now check the shape, 20,1. So there are total 20 observations and one column. So here we have successfully selected the real stock prices of the month November 2019. In this variable, real stock price. Now we have to predict the stock prices for the month November 2019. Getting predicted stock prices of month November 2019. To get the predicted stock prices of the month November 2019, we have to consider two important points. Let us discuss first one. We trained our model to predict stock prices of a day based on 60 previous stock prices. So, we will need 60 previous stock prices to predict each day stock price of the month November 2019. This is all about the first point. Let us discuss second point. We will need both training and test set for the prediction, and this is because we will need 60 previous stock prices to predict each day stock price of the month November 2019. For this prediction, we will select the data and we will store this data in a variable. Now define a variable dataset underscore total is equal to pd.concat we are doing concatenation here, so I will note down now we have to select a single column from training set and test set both. Scroll up, in data preprocessing. This is the training set. In training set, we have only one column. Now go to test set. This is our test set, real stock price. It has also a single column, open. If we select the data for prediction from training set and test set, then we have to apply feature scaling on that data, and as a result we will apply feature scaling on testing data, which is not recommended. We have to keep testing data as it is. Hence we will select the data for prediction from this variable training data, not from training set, and for the testing we will select the data from test data. Now scroll down, type training data. We have to select only one column, that is open. Then test data. Here also we will select same column, open. And after that we have to specify one more parameter, axis. Axis is equal to 0. Here we are concatenating this data on the basis of rows, not on the basis of columns. Hence, we have entered this parameter, axis is equal to 0. Now after the concatenation, we have to select 60 stock prices for each day of month November 2019. Stock prices of previous 60 days for each day of November 2019. To select stock prices of previous 60 days for each day of November 2019, define a variable inputs. Here we will select the data from this variable dataset underscore total. Now note down here, in this variable dataset underscore total, there are all the observations from training set and test set. That is all the observations from November 2014 to October 2019 plus all the observations from the month November 2019. Now from that all the stock prices, we have to select previous 60 days stock prices for each day of November 2019. And to do that, we have defined this variable inputs. And we have to select this data from this variable dataset underscore total. Type length dataset underscore total minus length test data minus 60 colon dot values. Let us understand this. LEN. When we subtract the length of test data from the dataset underscore total, then we will get previous 60 stock prices for the first day of November 2019. And after that we have added minus 60 colon. After adding this, we are getting stock prices of previous 60 days for each day of month November 2019. Now note down here, as of now this variable is a data frame. We have to convert this data frame into a NumPy array. And we will do that by reshaping. Convert into NumPy array. To do that, type inputs is equal to inputs dot reshape and in parentheses -1, 1. That's it. By doing that, we are converting this data frame into NumPy array. Now do the feature scaling. Inputs is equal to sc dot transform and in parentheses inputs. We have already defined this object sc. That's why we can directly apply feature scaling on this data inputs. Let us understand what we have done till now. First we have defined a variable, this one dataset underscore total, and in this variable we have selected all the observations from training and test data. After that we have selected stock prices of previous 60 days for each day of November 2019. So here in this variable inputs, we have 60 previous stock prices for each day of November 2019. Then we have converted this variable into NumPy array by applying reshape method, and after that we have applied feature scaling. Now we have to create a test set. Creating a test set. To do that we will use for loop. For I in range, specify lower bound is equal to 60 and upper bound is equal to 80. Let us understand this. We have to select stock prices of previous 60 days for each prediction. Hence, lower bound is equal to 60 and there will be total 80 observations in test set, that is 60 plus 20. 60 previous stock prices and 20 stock prices from the month November 2019. 60 plus 20, that is 80. Now we have to append this information in xtest. So define an empty list, xtest dot append I minus 60 colon I comma 0. Let us understand this. Here we are creating test set. Now consider minimum value of I, that is 60. 60 minus 60, 0. 0 to 60. That is, lower bound is 0 and upper bound is 60. Upper bound will be excluded. Hence, Python will select from index 0 to 59, total 60 values, and 0 is the column index. When I is equal to 60, then it will select previous 60 stock prices for the first day of November 2019, and so on. So this is all about this for loop. Now convert this xtest into numpy array, np.array xtest. Convert into numpy array. Now note down here, this xtest in 2 dimensions. But recurrent neural network takes input in 3 dimensions, so we have to convert this into 3 dimensions. Convert into 3D, and it is required to process type xtest is equal to np dot reshape xtest dot shape 0 xtest dot shape 1 comma 1. Let us understand this. So these are the number of labels, that is number of rows. Then these are the number of columns, and this is extra dimension that we are adding. Now we have to add one more step, getting predicted stock prices. Now define a variable predicted stock price. Type model dot predict method, and in parentheses xtest. Now note down here, we have applied feature scaling. Hence we will apply reverse feature scaling. Predicted underscore stock price is equal to sc dot inverse transform, and in parentheses xtest. That's it. Let us revise. First we have defined a variable test data. Now scroll down. There are total 20 observations in this data and total 7 columns. After that we defined one more variable, real stock price. So these are the real stock prices for the month November 2019. Here we have selected only one column, column open. So this is all about the selecting real stock price. After that we have to select predicted stock price. To do that, first we have applied concatenation. In concatenation we have selected the data from training data and test data. Then we have selected 60 stock price of previous 60 days for each day of November 2019. Then we have converted this variable inputs into numpy array, and after that we have applied feature scaling. Then we have defined x taste, and we have converted the same into numpy array, and after that we have converted these 2 dimensions into 3 dimensions, and at the end we have applied inverse transform. So this way we have selected predicted stock price. Before running this cell we have to do some changes. Delete this x taste and type predict stock price. One more change, we have to select this data that is in x taste from the variable inputs. That's it. Now execute. Great. So we have successfully created 2 variables, real stock price and predicted stock price. Let us do individual predictions. Print predicted stock price, specify any index location, then print real stock price, specify same index location, execute. So this is the predicted stock price and this is the actual stock price. Let us see one more example. Index 5, execute. Predicted stock price and actual stock price, and these 2 stock prices for the day 6, that is index 5. So this way we can do individual predictions. Let us revise. First we have defined a variable, this one, real stock price, and after that we have defined predicted stock price, and at the end we made individual predictions. So this tutorial about making predictions ends here. I will see you in the next one. Till then, happy learning. Hello and welcome to this tutorial. In previous tutorial we have made predictions. In this tutorial we will visualize the results. Let us begin. Type plt.plot, specify the variable real stock price, then specify the color red, then specify the label real Google stock price. Now copy this line, paste, delete this variable real stock price. Instead of that, type predicted stock price here also. Predicted Google stock price. We have to visualize and compare these 2 results, real stock price versus predicted stock price. Now type plt.title, Google stock price prediction. Then add X label, plt.xlabel, time. After that add Y label, plt.ylabel, Google stock price. Then plt.legend, and at the end plt.show. So here we have to visualize and compare these two results, real stock price versus predicted stock price. Change color here, blue for predicted stock price and red for real stock price. And after that we have added title, X label and Y label. Now execute. plt.show, execute again. Great. So this is the visualization of result. On the x-axis time and on the y-axis Google stock price. Real Google stock price in red and predicted Google stock price in blue. Let us analyze this. Let us first understand the trend of real Google stock price, this one. So it is increasing, then it is decreasing, increasing. Here we have peak, then decrease, increase. Now note down here in predicted Google stock price, here it is increasing, here not. Here a little peak, here also a peak, then it is increased here, and according to that predicted Google stock price is also increased, and so on. So we can say that our prediction is understanding the correlation. When real Google stock price increases, it is also increasing. So we can say that it is following same trend. Now scroll up. Before that we have made individual predictions. These are the predictions for a specific day. Predicted value versus real value. And this is the visualization. So this tutorial about visualizing the results ends here. I will see you in the next one. Till then, happy learning.